After the test has been implemented and we've collected all the data from the experiment, we can begin preparing the data for analysis. First, we'll clean the data to remove unwanted data points. Next, we'll calculate lift or difference in observations from treatment to control group. And lastly, we'll communicate our results. Cleaning data to remove unwanted data points is related only to control variables. It's unethical to remove data for reasons other than for control purposes. In the website optimization experiment, we want to prepare the data such that each individual IP address is only shown once. We'll consolidate records to accomplish this and possibly even remove some outliers. Second, we need to remove data for users who already have an account and would not need to sign up for an account since they wouldn't click on the link, and this would skew the data. We are interested in the propensity of users who do not have loyalty accounts in clicking on the link. Let's demonstrate how we'll prepare our data. Let's create an Alteryx workflow and import the data in the grocery website A/B test data file using the input data tool. We're also going to add a browse tool and run the workflow to take a look at our data. Before we start preparing the data, it's a good idea to ensure we understand the data we have. The record ID is just the identifier of the row of data, and the IP address is the address of the user who is visiting our website. The logged in flag is 1 if the user has an account and is logged in, and the server ID is one of the 3 servers that the user was routed through. Remember that server ID 2 and 3 represent the control group, and server ID 1 is the treatment group. The last column, visit page flag, is 1 if the user clicked on the page with information about the loyalty program. Users may have visited the site multiple times during the treatment period. An IP address is always routed to the same server, so an IP address cannot be in both treatment and control groups at the same time. For this experiment, let's say that if a user ever clicked through, we will count them as a 1, and if they never did, they will be counted as a 0. Since the data we imported is in a CSV file, all the fields will be loaded as strings. We'll convert the visit page flag to a numeric value to simplify our data preparation. Let's add a select tool and change the data type of the visit page flag to integer 16 since the value is always 1 or 0. Now, we can use a summarize tool and easily group all the rows of data by IP address, server ID, and logged in flag while summing the visit page flag field. The sum visit page flag field will be 0 if the user has never clicked on the link and 1 or more if they have. This will result in consolidating the data such that there is only 1 line per IP address. Now, we can use a simple formula to create a flag with the 1 and 0 values. Adding a formula tool onto the canvas, we'll create a new integer field named visit flag and use the formula if sum of visit flag field is not equal to 0, then 1. Otherwise 0. We are taking this step in case there are IP addresses with more than 1 visit. Let's also create a new field to identify the group the IP address falls into. We'll create a new string field named group with the formula if server ID equals 1, then treatment, otherwise control. Next, we need to filter out all the data where the user already has an account. Let's remove all records where the logged in flag field equals 1 using the filter tool. We can use a basic filter where the logged in flag does not equal 1. We'll add a browse tool to the T output and run the workflow to look at our results. Looking at our data, we are ready for analysis. We have the data indicating the group the visitor is in, whether or not they visited the page by clicking on the link. We don't have any people who have logged in, and we only have 1 row per visitor.